All right, everybody, we are on notes number 7 today, and we have two different things we're going to be looking at: solving radical equations and also doing some quadratic applications. So it's very likely that I'll end up changing this or splitting this lesson into two separate videos. So let's get started. The first part, we're going to solve some radical equations. So notice it says solve each equation for x, and we have a square root in our equation. So the logical thing to do to undo a square root would be to square. So let's square both sides of the equation. And remember, when you square a side, you square the entire side. You don't square the individual parts. So it's going to look like that. So the left side of the equation, we'll see the square root sign and the squared cancel each other out, leaving us with just 4x plus 13. But then on the right side of the equation, we have to actually multiply using the FOIL method. 2x minus 1 times 2x minus 1. So let's do that. So when we multiply those together using the FOIL method, we get 4x squared minus 4x plus 1. So now we have a quadratic equation and we're trying to solve it for x. So what I'm going to do is get everything over to one side. Might as well just get everything over to the right. So we'll subtract 4x from both sides and we'll subtract 13 from both sides. So we have 0 equals 4x squared minus 8x minus 12. Okay, looks like everything can be divided by 4, so let's divide both sides of the equation by 4, and we have 0 equals x squared minus 2x minus 3. And if you prefer to have the x on the left, we can just rewrite it like that. Okay, so from here, I do not know, let's see, maybe it's factorable. Let's try it. X minus 3 times x plus 1. Actually, it is. So we can solve by factoring. If you didn't want to solve by factoring, you could solve by completing the square or by the quadratic formula. Those two methods always work, and factoring doesn't always work. But we got lucky this time. So let's set each factor equal to 0 and solve each one. And we get x equals 3 or x equals negative 1. Now there's something else that we have to consider in this kind of problem. When you square an equation, you create a new equation, but the new equation might have more solutions than the original. So here's an example. Let's say if I start with the equation x equals 2. How many solutions does it have? One solution. Now what if I square the equation? Now I have the equation x squared equals 4. How many solutions does it have? Well, if I solve this, I get x equals plus or minus 2. It has two solutions. So if you square an equation or you raise an equation to any even power, the fourth power, sixth power, etc., you might introduce extra solutions that are not actually solutions to the original equation. That means they are extraneous. Extraneous solutions are not solutions to the original equation for whatever reason. Sometimes it's a story problem and they just don't make sense in that problem, or in this case, if you square both sides, you might end up with something that doesn't make sense in the original equation. So you have to eliminate them. They don't make sense for the problem. So what we need to do is we need to take each of these answers we got, 3 and negative 1, and we need to check these answers into our original equation and see if they work. Okay, so for the check, what I'm going to do is start with x equals 3 and go back to the original equation. The square root of 4 times 3 plus 12 equals 2 times 3 minus 1. Let's see if that's true. So whoops, that's not supposed to be 12, that's supposed to be 13. There we go. The square root of 12 plus 13 is the square root of 25, and the square root of 25 is 5. And then on the other side, 2 times 3 minus 1 would be 5. Okay, so that checks. So x equals 3 is a solution. Now let's check x equals negative 1. So we have the square root of 4 times negative 1 plus 13. And then on the other side, 2 times negative 1 minus 1. So the square root of 4 times 1, that would be negative 4 plus 13, that would be 9. So the square root of 9 is 3. And on the other side, we have negative 2 minus 1, negative 3. So 3 is not equal to negative 3. Now some people will say, wait a minute, I thought that the square root of 9 could be 3 or negative 3. Well, you have to pay attention to the notation. Remember, when you use a square root symbol, it means just the positive root. If you use words and you say, what are the square roots of 9, then you could have two answers. But if it's just a square root symbol, it means the positive one. So since 3 and negative 3 are not equal, x equals negative 1 is extraneous, so we need to eliminate that solution. Okay, let's do another example. Here's number 2, and we have a cube root on both sides, so what we're going to do is cube both sides. In the last problem, we squared both sides, and in this problem, we're going to cube both sides. Now, if you cube both sides, you don't have to worry about extraneous solutions. That's because cubes and cube roots only have one answer. The cube of a positive is positive, the cube of a negative is negative, and so on. So you don't end up with a plus or minus situation at all. Okay, when we cube the cube root of the left, we end up with just 2x, and on the right, the cube and the cube root cancel, and we end up with 5x plus 2. And then we can subtract 5x from both sides and divide both sides by negative 3, and we have x equals negative 2/3. Okay, let's take a look at number 3. Number 3 has two different radicals in it, so this one's going to be significantly more complicated to solve. What we're going to do, because we have square roots, is we're going to square both sides, but remember, you have to square the whole side, not the individual parts. So when we square the whole side on the left, it's like we're foiling with square root of x plus 5 minus 2 times square root of x plus 5 minus 2. And then on the right, the square and the square root cancel, so we just have x minus 1. So let's go ahead and use the FOIL method on the left, and when we multiply the firsts together, we get x plus 5, and when we multiply the outsides together, we get negative 2 times a radical. The insides, we get negative 2 times the same radical, so altogether we have negative 4 times a radical. And then when we multiply the last together, we have positive 4. So, believe it or not, we've made progress because we went from our original equation having two radicals in it to our new equation having just one radical in it. And what we're going to do to clean this up is let's isolate the radical. So let's subtract x from both sides and subtract 5 from both sides and subtract 4 from both sides. So that's going to give us negative 4 square root x plus 5 equals, so we're subtracting x and we're subtracting 9, so we get negative 10. Okay, you can probably imagine that the next step we're heading toward is like problem number 1, where we had a single radical in the equation and we squared both sides. So we're going to do that here. We're going to square both sides. But first, let's divide both sides by negative 2. You might decide you want to divide both sides by negative 4. However, I would caution against that because then you're introducing a fraction, and the problem is complicated enough without also introducing fractions. Okay, so now we are ready to square both sides again. And when you square the 2, you get a 4, and when you square the square root, you just get x plus 5, and then when you square the 5, you get 25. Okay, now let's distribute the 4. Subtract 20 from both sides, and divide both sides by 4, and we have x equals 5/4. Now remember that there is a possibility of extraneous solutions because we squared both sides of the equation. In fact, we did it twice. So we need to check our answer. So we have the square root of 5/4 plus 5 minus 2 equals the square root of 5/4 minus 1. Let's see here. The square root of 5/4 plus 5, that would be the same thing as the square root of 25/4, right? And the square root of 25/4 is 5/2. 5/2 minus 2 is 1/2. And then on the other side, 5/4 minus 1 is 1/4, and the square root of 1/4 is 1/2. So we don't need to eliminate our answer. It's not extraneous. Okay, so that's part 1 of today's lesson, and I'm going to end this video, and then part 2 is going to be solving some quadratic applications. Word problems, your favorite.